Hello, everyone. My name is Ruguma Ishtala. I am a PhD student at Pukyong National University. And in this presentation for the course of Global Topics in Artificial Intelligence, I would like to present to you about transfer learning of GPT model for other languages. The outline of the presentation looks as follows. So initially, I would like to share you some progress that has been done on large language models. And following that, I'll talk about the focal paper of this presentation, which is about recycling GPT-2 model for other languages. So let's go to the first part of this presentation. So human beings have had the desire and passion to build machines that can really understand them. So is the day where machines really understand us near is an intriguing question that has been on our minds. So when we look at the timeline, the department or the domain of natural language processing has been trying to generate texts that resemble that of what a human would write. So initially, we had language models that were based on RNNs, the RNN architecture. This was a good discovery. However, this approach had limited memory. The architecture had limited memory, and thus it would forget about what it was told or what it was generating a while back. And thus, these RNN-based language models were not able to generate a coherent sentence. And then came the discovery of the transformer architecture in the transformer model. This architecture resolved the issue of limited memory by the RNN architecture, where it was able to coherently make or generate long sentences. Initially, the transformer the paper that made the transformer used it for translation purpose. And following and building upon this, the GPT model came into life. This was a better, bigger, and stronger version of the uh, transformer architecture, where it's bundled it with embedding and other layers to create a powerful model that was able to learn the human language and generate as such. Here, I would like to briefly share the architecture of the GPT model. Initially, we have the text and position embedding layer. So this is important for later. And then we have the self-attention models here where the transformer architecture lies, and we have various normalization layers. So this is the general architecture, and whatever is learned here will be not enough for specific tasks. So the authors of the GPT-1 model also shared about classification, similarity, and multiple choice. So these application domains need further fine-tuning, and this is the structure of the fine-tuning they followed. When we come to the data, the GPT-1 model was largely trained on huge book data corpus, which includes 7,000 unique unpublished books. The model had 12 layer of decoder-only transformers and various settings, you can see here. So it had 768 dimensional states and 12 attention hits. This is the progression of the first GPT model. And when we come to the second GPT model, the main difference in the architecture, it's largely very similar, but the main difference in the architecture is the authors moved the position of the layer normalization layers. They expanded the vocabulary set, and they expanded the context size and the batch size. So the models become bigger with a little bit of a more improved architecture, but largely the same. When we come to the data of the GPT-2, so if you remember on the GPT-1, the data used was a book corpus of 7,000 books. But here in the GPT-2, what they did is they scraped the web. So they scraped Reddit. And so what they did is they got the Reddit posts that had votes more than 3. And they also did some analysis to remove duplicative data. And then they had 45 million links. And using those 45 million links of the Reddit posts, they trained their GPT-2 model. So this data you see here is largely based on the English language, but it's a huge data that was used to train the GPT-2 model. So this is the progress of the large language models and introduction to the GPT-1 and 2 architectures and models. Now let's go into the focal point of this presentation. So the paper I'm targeting is called As Good as New: How to Successfully Recycle English GPT-2 Models for Other Languages. This paper was published on finding of the Association for Computational Linguistics, and these are the two authors. It was published on the August of 2021. This paper, I chose this paper significantly because in this age, in this world, we have so many languages, and the benefits and advances we are seeing on the large language domain can be extended to all other languages, and finding ways on how to utilize such architectures for other languages is really beneficial. So to introduce you this paper, the authors argue that training a large language model from scratch for a different language is very costly. So instead, they recommend that adapting English-trained GPT models can reduce the time and the resources that would be required to train a large language model. So this approach is very effective because other languages with low resources can benefit from the learning that was done on an English model, because there are vast amount of resources on the English language. Also, what they propose is, so retraining the lexical embedding. If you remember, there's an embedding layer on the GPT model. So if we retraining the lexical embedding without fine-tuning the transformer layers would somehow help to transfer the GPT model into another language while requiring less training. So what the authors also suggest is we can train a smaller model, a smaller GPT model, and we can later upscale it to a larger model by transferring those relearned lexical embeddings. This paper, the authors they target the Italian and Dutch language, so they're trying to transfer the GPT-2 model to the Italian and to the Dutch language. So how do they do that? So the first step is to develop a byte per encoding vocabulary for each language. And then after developing that, we will train only the lexical embedding of the small GPT-2 model. And we will keep the transformer layers frozen in order to prevent a catastrophic forgetting that was done while learning the English language. So we don't want to forget that. We just want to fine tune it to a new language. So we will freeze the transformer layer and only train the lexical embedding to create a mapping between the English and the language model. Something to note here is this process by itself is also somehow computationally intensive, because even though we have frozen the transformer layers, in order to retrain the lexical embeddings, we have to do forward and back propagation through the whole layer. So this is also computationally intensive, but what the authors argue is this will stabilize in just one or two. The model will stabilize in just one or two epochs. Unlike if we're training a full model from scratch, it will take much longer time to stabilize. The third step is, for instance, if we want to scale up, so we trained a small model initially. So if we want to scale up, we can scale the small GPT model into a medium, let's say medium GPT-2 model, by transferring the relearned lexical embeddings. And also we can further train the lexical embedding at the target further train lexical embedding at the target model size. Finally, in order to make the model more accurate and more powerful, we can unfreeze the full model and fine tune it with the resources of the new language. Something to note here is the learning rate has to be set really, really, really low. Otherwise, the model will forget what was learned on the previous language. We don't want that. We don't want catastrophic forgetting. So if we are fine tuning the full target model, then the learning rate has to be really low. So when we come to the methodology, this research adapts GPT-2 model to the Italian and Dutch languages, and the model they used is the GPT-2 small and medium versions. For training, they used data sets that were available online. For the Italian language, they used Wikipedia and IT web data text. These two data sets are very huge, large data sets. And for the Dutch, they used a combined dataset of Wikipedia, news article, books, and various Dutch news source sites. And as you can see on the screen, the size of this data is huge. For the evaluation of the models, the authors used various sources that were available in the Italian and Dutch languages. So the tokenization for the datasets was used by utilizing byte pair encoding. And for computation, all of the models that are trained using this research were trained on 8 parallel NVIDIA V100 GPUs with 32 gigabytes of memory. So the authors also utilized PyTorch Lighting, and the transformer library for efficient implementation of the models. Now, so as I mentioned, relearning the lexical embedding is not an easy feat. So a lot has to be done to relearn the lexical embeddings. And the computational intensity is high. So what the authors did to reduce the training time is the following 4 strategies. First, the authors used a 16-bit automatic mixed precisioning, which cuts the training time by 2 or 3 times. They also split the documents into 128 token windows for the lexical embeddings. Also, to minimize the padding within the mini batch, they applied bucketed random sampling. And finally, in order to utilize the GPU to the full capacity, but also not to overflow the data, they maximized the batch sizes to fit the GPU memory. And they performed back propagation every 200 examples. This helped the authors to reduce the training time for the approach they have proposed in this research. So what are the outcomes of this research? So three models, both for Italian and the Dutch language, were the results of this research. So first, a GPT small model with relearned lexical embeddings is one of the models. Second, a GPT, so they will take the first model that had relearned lexical embeddings, and then they will fine tune it with additional resources on the target language. And also, if the small model is if they wanted to scale up, so they scaled up the small model to the medium size GPT model. However, how they did this is they used the relearned lexical embeddings of the small model to initialize the lexical embeddings of the medium model, and they used an approach called least square method to do this. So what are the results of this research? So the authors of this research conducted both automatic and human-based evaluations for both languages. For the automatic evaluation, the authors compared the perplexity scores on unseen test data with vocabularies of 30,000 tokens. But this does not give us the full picture. Sometimes some models may be able to give us a good perplexity score without being really good. Sometimes a human evaluation is also necessary, and the authors just did that. And how they did this is with using native speakers. So native participants of native speakers were used to evaluate the generated large language models. For the Italian models, 24 participants with the median age of 46 were used. And for the Dutch models, 15 participants with the median age of 27 were used. And the demographics include both genders. And when we come to the model results, here we can see on the bottom you can see a chart, and on the left is the human judgment score for Italian text, and on the right is the human judgment score for the Dutch text. So let me briefly tell you. So gold means human generated text. This one is the small GPT model. The orange bar is a small GPT model with relearned lexical embedding. The green one is a small GPT model with relearned lexical embeddings and fine-tuned data. The red is medium-sized GPT model with relearned lexical embeddings. And a special case for Italian is there is on the purple is a GPT model that was trained from scratch on Italian resources available for the Italian language. So when we compare this, I think without a doubt, the gold is human written text. The human written text is judged as highly by the participants, and that should be the case. But among the other models, you can see that the small GPT model with fine-tuned data scores the highest pose on the Italian and on the Dutch side. So it's very interesting to see this comparison, and I believe the human evaluation was very insightful. When we come to the details of how they did this, so they used 100 sentences were evaluated for each Italian and Dutch language conditions. So the 5 conditions I just mentioned: the gold, the small lexical, the small fine-tuned, and the medium lexical updated models. Each had 100 sentences evaluated. And out of the participants, each participant evaluated 50 to 150 sentences. So each sentence was evaluated 3 to 5 times. So this redundant repetition is very important. And I think the authors did a good job in trying to reduce bias. So the sentences, the models were evaluated multiple times by different participants. Also, this will take the total evaluation for the Italian text to around 2,000, and the Dutch text are to around 1,500. To further reduce the bias that would be introduced by the selection process, sentences were actually randomly generated using beam search with a temperature of 3.0 for the GPT model. I believe they chose this temperature to regulate between curiosity and repeatedness. So if the temperature is too low, the models will generate the same sentences again and again. But if the temperature is too high, there would be too much randomness. So they chose the temperature of 3.0, but the authors have not signified why they chose this number. So they should have done that, in my view. But I believe it's an acceptable temperature of the GPT model. When we come to the evaluation of the automatic approach, so we talked about the humans, using human participants. Now, when we see the automatic approach of the three models, that means the small lexical relearned, the small fine-tuned, and the medium lexical relearned of the GPT models that were transferred to the target languages. The small GPT model with additional fine-tuning achieves the highest score. It's a very insightful. So for the Italian, so let's go to the graph here. Here on the left, you can see the perplexity score for the Italian dataset, and on the right, you can see the perplexity score for the Dutch. So here we can see that the small GPT model, which had the relearned lexical embeddings and some fine tuning, almost achieves high score on all aspects of social, news, or legal topics on the Italian aspect. And for the Dutch, the small GPT model with relearned lexical embedding and some fine tuning achieves high score on the topics you see here on all of them. So this model has shown superiority, and even in the Italian case, if you remember, we had a GPT model that was trained from scratch. So this model, this small GPT model, performs almost as good as the GPT model that was trained from scratch. So this is very insightful because it didn't take that. I'm sure it can be observed that the relearning, the lexical relearning, will not take much resources as the GPT model trained from scratch, but it performs almost as good. So this is a very insightful finding. So what are the limitations of this research? So relearning the lexical embedding of a new vocabulary requires the full forward and backward propagation of the whole model. Now, even though we are relearning only the lexical embeddings, such approach is still a costly. This is still costly. We would need V100 NVIDIA GPUs just to perform this. So where is the benefit? What other things can be done to reduce? If we are transfer learning GPT models, then uh, if we're training the full model forward and backward, then uh, this is still costly. What other things can be done? So something the authors that they suggest is to if we want to train a larger model, then they suggest that first relearn the lexical embeddings on a smaller model, right? After learning the lexical embedding of the smaller model, then they suggest that using this lexical embedding that was learned, we can use this to initialize the lexical embedding of the larger model. So, so in this case, they used the medium GPT model, and then they improved it. They got the initialization from the small GPT model, and then they initialized it for the medium one. But what happens if we want to fine tune the larger model? Then I believe we're still going to need some large scale training, which will require a higher set of computational requirement. So in my view, so in this slide, actually, I'm discussing my observations and my views, and I think what the author suggested is very insightful, and it's a very good presentation. I highly agree with what they have discovered, but I believe more work has to be done to reduce the computational intensity and requirement of such models. Uh, and what if we need to use GPT-3 models or Llama models is also some considerations that has to be taken into account. With that, I will finish my presentation. Thank you very much for your time.